Should understand about the AC circuit and the DC circuit and what is the difference between these two circuit. So let us start with our basic diagram of AC circuit. Before that, let me take the pen. So here we are. This is an resistance. I don't know why I can't really draw faster in this. It becomes okay. Anyway, so this is an voltage source, AC voltage source, and this is an resistance. This is a resistance here, and this is called AC circuit CKT. Uh, this is K, right? And when it is DC, we show it as a battery. This is the resistance, and this is how it is. This is the voltage, and current will flow through this. Here is the resistance. In this case also, current will flow like this, right? Now if we look at the waveform for this waveform is this side is amplitude, and this side is time. So this is time, and this is amplitude. AMPLITUDE. So it can be current or voltage, both. So now let me show how the waveform will look like. So waveform will look like something like this. So maybe this is current, and voltage waveform will look like something like this. Oh, something like this. So what I wanted to show is that this is changing its direction over time. But if I look into this circuit, the current may be like this and voltage may be like this. So this is current and this is voltage. Both are straight lines over time, right? No changing. So this is called DC circuit. Now there is one more fundamental difference. We need to understand what is reactance. I mean, what is of course what is reactance. I mean, there are two part of reactance. One is called capacitive reactance. Capacitive reactance, right? AC reactance, and something called inductive reactance. Now what is this XC? It is symbolizes as XC. The formula is 1 by 2 pi FC. And what is inductive reactance? XL. The formula is 2 pi FL. Now look at this. What is called F? F is nothing but frequency. Frequency. Frequency is number of cycle per second. Right. Now, in case of DC, just look at it. In case of DC, there is no frequency because it is straight line, no occurrence. But in case of AC, so there is positive and negative. So after a certain time, again there will be a positive uh, cycle, and then again a negative part of it. So there is an occurrence of it. So if we think frequency, for example, if you are living in a metro city, then you might be very familiar with the question that what is the frequency of this bus, what is the frequency of this train, like that. So people will answer like every 15 minute it comes. So this is the occurrence, right? Every 15 minute. So what is the frequency? Frequency is occurrence of something um, after a certain duration over a period of time. Now for the example of bus, if it is 15 minute, then within 1 hour it will be 4 times, right? So the cycle per second, cycle per hour is 4 per hour. Similarly, we can understand the electrical circuit the same way. Number of repetition per second, right? Number of repetition per second. Number of repetition means this is one repetition. Similarly, it can repeat after again and again and again. So if we calculate it, how many times it repeats, that is the how many time it repeats in a second, that is the cycle per second. Now, in case of DC, let me show you this. In case of DC, what is the what is the value of F? F equal to 0. So what will happen to this? XL equal to 0. And what will happen to this? XC equal to XC is equal to 1 by 0. So it is almost infinite. Uh, now, uh, it means in case of DC circuit, right? In case of DC circuit, there is no there is no inductance or capacitance, and there is no value of it. Only resistance will be there in case of DC circuit. DC, right? This is DC. Only resistance. In case of AC, we are showing resistance, but along with that, there will be inductor and there will be capacitor in the circuit. So, and that's it. That is the major difference. Now, let me summarize what I have discussed. So, in case of alternating current, the direction changes periodically. In case of direct current, it flows constantly in one direction. Now, the waveform, it can be sinusoidal. So we are looking after the sinusoidal waveform every time. But it can also be square wave or triangular wave. For example, so what I was talking is this is an sine wave, right? This is a sine wave like this. It is a sine wave, but it can be a rectangular wave like this. It can be a rectangular wave like this, or it can be a triangular wave also like this. Hmm? All of them are alternating current. Now, alternating current generally comes with 40 and 50 hertz. 50 hertz means 50 cycle per second, or 60 hertz means 60 cycle per second. So in India, it is 50 hertz the rating, and in Europe or America, it is 60 hertz. But for DC, it is 0. Transmission, because of use of transformers, it is easy to transmit in the longer distance. Whereas in case of DC, the transformer doesn't work in case of DC. We'll understand later how why the transformer does not work in case of DC. Even though we can go for high voltage over using some solid state devices, which is very costly, and source is like of course the power plant or alternator are the source of alternating current. And in case of DC, it is the battery, solar panel, and DC generator. These are the sources. And I think, yeah, that's it. Thank you.